Okay, so today I'm going to be talking about electric vehicles and towing as far as aerodynamics is concerned. So pretty much there are three main issues with electric vehicles and towing. One being the range of the battery, the second being cooling the battery, and the third is aerodynamics, which is what we'll be focusing on. Now, of course, aerodynamics is taken into consideration with all vehicles, but it's most prominent in electric vehicles. This is because range is such a concern with the vehicles. So in order to simulate a vehicle traveling at higher speeds on a road, I've set up this ramp with a leaf blower to simulate the wind speeds, which I'll be releasing the cars from. Now I have the cars set up so that the back is lined up with that knot. So this is the car shown with its aerodynamics in place. So now I've set up that same car with this piece of cardboard attached to the front to eliminate any aerodynamics. You can see what a significant difference that makes. Here's it side by side. Okay, so now let's look at some of the math behind it. So the formula is 1/2 the density of air times velocity squared times the coefficient of drag times the frontal area. So the frontal area is pretty simple. It's just pretty much the size of the vehicle. So you get it just by looking at the front of the vehicle and looking at how large it is. So you can see here I've drawn the front of the vehicle on here, and it's 3.75 inches across and 2 inches tall to give an area of 7.5. Now the shield I made is 4.25 inches across and 5 inches tall to give an area of 21.25. So when we plug that into the formula, we have 1/2 times the density of air times our velocity squared in feet per second times the coefficient of drag of the vehicle times the frontal area in feet squared, which gives us 0.089 pounds of force or 0.396 newtons. So now with the shield, we have our 1/2 times the density of air times our velocity, which is the same, and then times 1 because there's no aerodynamics here, and then times our frontal area. And with that, we get 0.606 or 2.7 newtons, which is significantly more than our 0.396 newtons. So aerodynamics definitely makes a clear difference in the force exerted on the vehicle when driving at higher speeds. So let's talk about why this is important for electric vehicles and towing. So of course, knowing the difference that aerodynamics can make in the efficiency of a vehicle, they've been designed to be very aerodynamic to increase the range. However, adding the flat object behind it like a trailer can completely eliminate those aerodynamics. So just as we saw, adding this flat object behind the vehicle significantly increases the force and energy needed to move the vehicle. Because so much more force is needed, it drains the battery much faster, restricting how far you can travel before having to recharge.